In today's lecture, we're going to discuss the aggregation framework, which is part of MongoDB, and it's going to help me to find certain results that belong to some sort of aggregation operations that we do over our data. So let's discuss what is aggregation. Aggregation is simply processing the results to calculate certain value. An example of that in SQL, that would be group by. Every single time you use a group by, you use some sort of an operation with it, and you say, I want to use count, for example. Count in a group by is an operation. And every single time you want to group certain fields in SQL, you have to pick what field you want to group by. And you could as well group by multiple fields. We will do the same operations, but in MongoDB with a NoSQL database. Now in NoSQL, we have already seen single-purpose aggregation operations. For example, we've seen something called collection.count. The count method here is a single-purpose aggregation method that you can use to find the count of documents that match the query. However, in MongoDB, we have also a dedicated framework to calculate all the aggregation operations and find the data that we want. And in order to use this pipeline, we are going to use a method called aggregate. So we have on the db.collection a method that's called aggregate. Of course, data collection, you can replace it with a method or CLI or a model name. They're all the same. Aggregate method exists on collection level or the model level. Now, every single time you call aggregate, what you create is a pipeline. And this pipeline consists of at least one stage or more. But at least you have to mention one stage. That's why what we pass to aggregate method is an array of stages. Here I have first stage, I mentioned first stage. Then I have another stage, you have to mention another stage. Then you have another stage, then you have to mention the other stage. So stage 1, stage 2, stage 0, etc. Now the first stage inside this pipeline reads its data from the original database. That's the input. And passes an output that is considered an input to the next stage. Stage 1 cannot read data from the database. Stage 2 cannot read. The data travel in sequential order. Stage 1 input is the output of stage 0. Stage 2 input is the output of stage 1, and in the end you get a cursor, or if you're using Mongoose, you will get immediately the array of the results that were processed within the pipeline. Now you may choose to persist these results back in the DB. I don't see why you want to do that because you always want fresh data, or you just consume the data and send it out as a response. Now every single stage has a limitation of 100 megabytes. Another stage, another 100 megabytes. Stage 3, another 100 megabytes. If you want to exceed this limitation, then you should pass options to the aggregate methods and say that I want to use the disk. If you do that, then your aggregation certainly is going to be slower, but you overcome the limitation of 100 megabyte per processing stage. Now, this pipeline of 3 stages could go up to 300 megabytes. So this is really a large amount of data to be processed. Now, what kind of processes we do have? The process could be a group by, could be project, could be match, could be a sort, could be limit, could be a skip, could be unwind, and there are others as well. All of these are type of stages. And these stages don't have pre-assumed order. The stages are executed in the order that you specify them inside this array. So if I wanted to create a limit as first stage, then you only select, let's say I want to limit 5. Then you only take 5 documents, the first 5, and you pass them through. So basically, the stages are processed in order of how you mention them inside the array that you pass to aggregate. And you can use a certain stage 1 or more time. So the first stage is limit 5. The second stage could be some sort of a group by. And then stage number 2, you can just limit again and select only one document and send it out. So there is no limitation to how many times you use each stage inside the pipeline. So that's a general idea of the aggregation pipeline that we want to work with. And we use aggregation just to read data, just to accumulate some data and read them in a certain way that help me understand the data better. Now, one last note here is that only the first stage, stage number 1, here I said it's 0, takes advantage of any indexes that you might have over your collection. So as I mentioned, the aggregation is going over the collection. And since the first stage reads its data from the collection itself, then it will take advantage of any indexes that you might have. So maybe it's a good idea that you first try to filter out this or query certain data from the database. Take advantage that this query will run really fast using the indexes, and then pass the data forward to the next stage. Second stage, third stage, etc. They can never use the index. They just process the data in memory and pass it to the next stage. Any questions? Let's go over some details about each of these stages and learn how we use them. The first one we will look at is the group by. And group by works as an upsert operation. So what is an upsert operation? It's either going to insert if it finds an ID that you pick, or it's going to update the results in memory if the ID is found. So here is no ID, and here's I do have an ID. And of course, the insert and update always is processing data in memory. So it's no real documents are inserted or updated on the collection. The data in the collection never changes as a result of an aggregation. So let's see how we can pick an ID, how we can group by documents within our collection. Here, as you can see, upstairs, I have a table. This is SQL. I have a table, and I said select manufacturer. I picked an aggregation operation, and I said I want to group by manufacturer. And what's going to happen? This count is the operation that you're trying to aggregate with. Manufacturer, how many manufacturers I have? 2. 3 Apples and 1 Google. So this and this and this will be aggregated together. And this one doesn't have any match, so it's going to remain the same. And the count will always add 1 every single time you find same value that you group by. That's why a query like this will give you these results. Now we can accomplish the same thing in NoSQL. Let's assume that we have this same set of kind of data, but in a document form. So each row is a document. And now the way that we process the aggregation, as I mentioned, over the collection level, we call a method called aggregate. And what we pass to aggregate is an array of stages. And here, as you can see, I defined one stage, which is group by. This single stage is going to read the data from the collection and send results back as an output in memory so you can read the results. So how does aggregation really work? In order to specify you want to group by which property, you need to mention this property name inside underscore ID of a group. So the manufacturer here is set when you set the underscore ID for which property you want to aggregate with. Now, if you have a stage and you want to read data from a previous stage, every single time you want to read data from the previous stage, you have to add the $ before the property name. So when I see here that the underscore ID value is $manufacturer, this $ only means that from the previous stage, I should have a property called manufacturer. The previous stage of this group by is the document itself. And yes, inside the document, I have a property called manufacturers. So that's what the $ basically means. All it means when you see a $ at the right side of a column, it means find in the previous stage a property called manufacturer and read its value. Here I'm creating a new property, then I call it num_products. So as you can see, I am grouping by ID, and I created another property, num_products. Now, every single property that you add to this stage must use one of the aggregation operators. And here's someone kind of match count star, because I want to add the value of 1 for every single time I find a match of the property value that I try to aggregate over. So let's explain how does this absurd operation really work. So the first time the first document arrives, I'm going to create a document in memory with underscore ID and num_products. Now, the first value of manufacturer from the previous stage is Apple, Do I have anything in memory? Nope. So add here Apple. And inside non-products, you're gonna add 1. So here is 1. Next document. The underscore ID would be manufacturer, which is Google. Do I have Google? Nope. So I'm going to insert in memory. You will have Google. Non-products, again, sum 1. So you add the value of 1. Third document. ID is manufacturer. The manufacturer is Apple. Do I have Apple? Yes. So I'm going to update this document in memory. And now I'm going to add 1, sum 1, so it becomes 2. The fourth document, same thing. I already have Apple. I'm going to update Apple and sum 1. 2 plus 1 is 3. And basically, this is the result that you get as output of this aggregation pipeline. Any questions?
I have
Let's
a
see more.
question. So
Yes.
the line $sum1, so we can put 1 or 0, right? 0 is nothing and 1 is calculated sum,
Yes.
right?
Yes, this is the value that you want to add, correct. So if you say -1, basically you decrease the value. If you say 5, you just increment 5. If I want to add, for example, the price, then you add $ price. So read this value from the previous stage. So you can add basically any value to increment or decrement the existing number.
Thanks. Thank you.
Sure. Any other questions?
I have a question.
Yes.
So after sum, we just specify a number only, or we can specify the logic here. For example,
yeah, you can specify some also calculated value in JavaScript. You can pass an expression that results into a number.
yes, a function return a number here, right?
Yes, correct.
Okay, thank you.
Perfect. Okay,
Yes.
Professor.
Question? Yes.
For example, in the aggregation like sum, if I want to use if I wanted to know if there's like a way to use like a field in the result, for example,
Yes. Yes, that's what I
the price,
mentioned.
if I want like to use like the value of the price dynamically.
Yeah, so you can say price. In this way, Google would be 500 and non-products would be 800 plus 600 plus 900.
Okay, thank you.
If you replace one with the price. Yes.
Yeah, so the $ before the manufacturer, what does it represent, you said? I didn't get quite that part.
Yes. So when you create a property and the right side of the property has a $, some name, this $ means read from previous stage the value of this property. So when I say $ manufacturer, I have stage number 0 here, the first one. The previous stage is the collection itself. So basically I'm reading this. And when I mentioned here $ price, the previous stage is the document. So I'm gonna find a property called price and read its value. So that's what the $ means when it's mentioned at the right side of the column. If there is $ at the left side of the column, this is the name of the operator. So in this case here, it's sum. It's an operator name. Any questions? Let's see more examples to help us understand more about group by. Using the same data set, all I did in this example is to create a label just to make my results more meaningful. Because to have an ID with the value Google doesn't make any sense. But if I have an ID that has a label manufacturer and the value is Google, which would make a little bit more sense. So I'm still grouping by the manufacturer, but I just gave this manufacturer a label to represent what this value represents. The next example on this slide is using a compound key to create the group by operation. So what I group by now is by two fields with two labels. The first one is manufacturer, the second one is category. So let's take a look back at the data and see what happens when I group by manufacturer and category at the same time. Here's our data. So I'm going to group by the category and manufacturer together. Tablet Apple, first unique. Phone Google, unique. Phone Apple, another unique. Tablet Apple, now this tablet Apple and this tablet Apple is going to be merged or grouped by together, because now I'm grouping by both values. So the result would be an aggregation of 3 results in memory. The first one is the combination of this, second one, and third one. So what am I doing in this aggregation query? Let's see. Also, I'm adding sum 1. This is why we're seeing Google Phone 1, Apple Phone 1, but Apple Tablet, I'm seeing the number of 2 because the first and last documents were grouped by and I calculated the sum. Any questions? Let's see more examples. Yes?
ID, what is it doing?
Say it again, please.
The ID and underscore ID, what is it presenting?
When you say group by, ID means by. Because this is the unique value that you're trying to group by this value. So every single time you receive another ID, you're going to update. If the ID you didn't find the underscore ID in memory, then you're going to insert this value in memory. So basically the ID is what we understand from SQL word is the value that you group by it. Okay?
Thank you.
And you can use a single field to group by or multiple fields to group by. So a group operation must at least have 2 fields, at least. Which field you're going to group by with, and we represent that with underscore ID. And also you must have at least one, any property name you can pick up, but at least you need to use one operator, aggregation operator for the group by. And here I use sum. Otherwise, the group by doesn't make any sense. Any other questions?
Professor?
Yes.
Professor,
Yes.
if I only need to display like the category name, I don't need like the count of it. Or how can I handle it?
I'm gonna show you some tools that you can do that with. So it's coming. Any more questions? Let's see more varieties and tools that we can use with group by.
Okay, thank you.
So additional to sum, there are so many other operators that we can use with group by, like average, min and max. You have push that will create an array, add to set that will also create an array, but it's going to be unique because it's a set. And we have the first and last. From the name, probably you might have guessed what each of these would do. So let's use some of them. I'm using the same data set here. first aggregation query. As you can see, I'm omitting here the db.collection, but you must add it. So it's similar to yesterday's slide. I just don't want to complicate the slides. But there is no aggregate global methods. The method exists on the collection dot. Okay. So I group by manufacturer, and I created a property called sum prices. And the value of sum prices is basically the sum of price, something that we already discussed. So we have Google here as 500, and Apple is the sum of 800 plus 600 plus 900. Next, I'm using here the average, and I am grouping by the category. So I'm trying to find the average price of a tablet and an average price to phones. So the average price of a tablet is 800 plus 900 divided by 2, and the average of the phone is 500 plus 600 divided by 2, and hence we see this results. The third example here, I group by manufacturer, so 3 Apples and 1 Google. And what I want to do is, what is the most expensive product of this certain manufacturer? So I use the operator max. So when we upsert, Apple 800, Google 500, Apple 600, but I'm using the max, so 500 doesn't do anything. Next, I have Apple 900. 900 is higher than 800. So 900 will replace the 800, and that's basically the results that we receive. The max price would be 500 for Google products, and for Apple products, the maximum, most expensive product is at $900. Now, how can I carry some data? We were going to use push and add to set. Let's take a look at more examples. Any questions about sum, average, and max?
Sir, I still didn't get that. Have we grouped by 2 properties? That manufacturers.
Yes. So at some point in the previous slide, I tried to group by 2 properties, which is category and manufacturer. Did you see that? Here, manufacturer and category. So only a unique value between this combination, it's going to be aggregated, grouped together. So let's take a look at the values of category and manufacturer. The first value is tablet Apple, unique so far. Second one is phone Google, unique. Third one, phone Apple, still unique. Now the last one is tablet Apple. I already have tablet Apple. So the first and last document would be aggregated together or grouped together because that's the unique value of the combination of category and manufacturer. Is it clear now?
Yes, Professor. Yeah, thank you.
Professor, I
Any
have
other
a question.
question? Yes. Yeah.
Can we use 2 operators in the same group?
Yes, you can add as many operators that you need inside the group by. And probably some examples are coming next. Any other questions? Let's see more examples. And here I'm finally using add to set and push. In both these aggregation queries, I group by manufacturer. So basically, since only Apple has a repeated value, I'm going to aggregate the Apple products. Google will just find its way as is. So what I'm doing here when I used add to set is I'm creating an array inside categories property. And every single time I'm going to push the category value inside this array. But if the category value is already pushed, I'm not going to push it again because I'm treating this array as a set. That's unlike push operator. Push operator is going to create an array as a value of categories, and it's going to push the category value inside whether it did exist or not. So the array, the result of Apple products is going to be tablet, phone. Tablet will not be pushed again inside categories because we're treating this array as a set. While in the next example, when I use only push, I see that I pushed tablet and phone and tablet inside the array, and I have now 3 values as an aggregation for Apple products. So that's how we can carry some data and basically maintain some data to be carried into the next stage. Next. Any questions? As we move forward, you will see more meaningful use of each stage, and we're starting with very simple data set, but as we move forward, you will see like a little bit more examples. And afternoon, when we meet again, we're going to probably convert some of the yesterday's queries to use the aggregation pipeline. And remember yesterday when we needed to read the brand by ID, we had a small issue, and that issue was we couldn't just select this brands. We always had to get a lot of results to our server, and we didn't want to just like filter them inside Node. The database, if I'm asking for a single brand, shouldn't send me back a single brand. It shouldn't send me all the brands and I have to filter them. That's not the job of my server. So we will see also, we will work on that in the afternoon with the aggregation pipeline to see how we can solve this problem.
Professor, can I have a question?
Yes.
With the add to set, in this case, it can know the difference between the screen with phone and tablet, but in case of array of objects, it can know the difference between the object.
Very good question. What if the value of one of these is an object? MongoDB treats an object as one binary value. So if I have x5 and y7, this object as a whole value is 1111000. So if another value came as y7 and x5, that does not match this value because the binary representation of this object would be 00001111. Okay? So of course, the binary representation is not this one, but I'm just giving you an example that the object is read as one value in this case. So only an exact match would aggregate the results. Any other questions? Unless you say, for example, let's say category is an object and you say category.x. In this way, even though the order is different, the value of x would be just number 5, which do match. So it's up to what you want to aggregate by or read value from. Any other questions? Let's learn another stage, which is projects. And project is one of the easiest stages that we can add into our pipeline, and the job is projection. So what do we do in projection? We turn things on, we turn things off, right? And that's what we are probably doing here. So the main purpose of project is to reshape our object to make it more UI friendly or consumer friendly. So if I have this data and I want to make them in a more way, I think we all agree that if I have a maker, the detail about the category and the price and the item, probably this data is much more consumable than this one. It's the same thing, but we're just doing some beautification here. So inside aggregate, I also have one stage, and I use the stage called project. And what I did here is turn off underscore ID. So when I say underscore ID 0, it means turn off underscore ID. Create maker details item. Maker details item. The maker is the lowercase of manufacturer. Manufacturer in lowercase comes here. Details is an object that has category and price. The value of category is previous stage category. So you pass category here. The price is the multiply of the price times 10. So here's the price times 10 is here. And the item is the previous stage name property. Here's the name property, comes here. So all I did is reshape this object by turning off, creating new properties, more meaningful properties, and carrying on data from the previous stage in here. So that's basically how projection works. Any questions? One of the most important stage that we may use is match. Match is basically sending a query. Now, when you have a pipeline and you have any other, like for example, project or group by. Now, these kind of stages, when they are at the first stage of your pipeline, they're going to read the entire collection documents. So if you have 1 million documents, all of them, they will be part of the aggregation of the first stage. But if I have a query here, hey, I want to aggregate the states of Iowa instead of the entire United States. I want to aggregate the city of Fairfield. So you just pick Fairfield documents at the first stage, and then you carry on next. It's wrong that you start with the full collection and then you just downsize your data. Try at first to take advantage of querying part of your data and then aggregate this as you move forward. And remember, the first stage take advantage of the index, and that's a good thing. So you probably want to always start with match, then you could group by or do something, and usually we have the projection as the last stage. So we like to start with match always as stage number 1, process, and we like to end with projection, just to beautify the results and make it consumable friendly. That's usual, but there are no rules. You can always start with the projection if you'd like to. And here we're seeing a collection that represents zip codes of the United States. And you probably noticed already that the zip code number is a unique value. So instead of having object ID for underscore ID, I save the zip code value as an ID value. And they are always unique. We don't have 2 states or 2 areas in the United States that have 2 matching IDs. This is why this value works as underscore ID. Here we have the city name, city location, the population inside the zip code, and the code of the state that this code exists within. Now here, I'm aggregating over the zip collection. And I have 3 stages inside this pipeline. The first one is match. The second one is group by. And the third one is project, which is the order I already told you that it's more common that we process data within. The first one is filtration, process, and then beautification. Let's take a look at the first one. Hey, pick only here we have all the states, okay? Pick only the documents that have state of Iowa. So we pick only small group of the large collection of zip codes of the United States. Now this output would be an input to the next stage. The input for the first stage is the collection as a whole. I filter some documents and I pass them as input to the next stage. The next stage is I'm grouping by city, and I sum all the population within the city and add to set the zip codes inside this array that I create, zip codes. The output of this group by would be an input to the projection. And after I finish my beautification of projection, I get this data set. So let's go over the steps one by one. How does this work? First, match IA. So if I have other states, I get rid of them. This is stage number 1. Now, the remaining states of Iowa is the input for the stage number 2. Stage number 2 is going to create upsert in memory. With underscore ID, I group by the city. So here the city is Fairfield, Burlington, Mount Pleasant, Coralville, and Iowa City, Iowa City, Iowa City. So this 3 will be grouped by. The others just gonna be inserted. So let's insert one of them. I don't want to do it all of them. Let's say I'm going to insert the Fairfield one. So ID is Fairfield. Next, population. The population would be population is the sum of pop. So basically, I just have one value here, 12147, comma. Zip code is an array treated as a set. So the zip codes is an array treated as a set, which is I'm going to add the underscore ID value, which is the zip code 52556. The next one is Burlington. Next one is Mount Pleasant. Next one is Coralville. And the next one is Iowa City. All right, let's see the case of Iowa City. Iowa City. Population is 25049. Zip codes is an array. And I will push 52240. The next time I see the next document, I see also Iowa City. I group by Iowa City. So I'm going to update this Iowa City. Sum the population, so plus 21140. And I'm going to push this zip code into this array, comma, 52245. The third document arrived, same Iowa City, plus 22869, and I push the zip codes into this array 52246, and that's basically the output that's going to be input to the projection. So now I'm going to convert this into whatever this projection is telling me. And this projection is basically just renaming this first property. The first property, look at it, it's called ID, and the value is the city name. So it doesn't make sense. So I said hide underscore ID, create a property called city that takes its data from the underscore ID. So this is a technique to rename certain property that I have. And I said, keep population as is, keep zip codes as is, and that's basically now the results of the projection. Any questions?
Yes, Professor. So the very first database collection zips, I'm confused with that. What is it doing there? Why are we putting the zips in there?
Oh, do you mean this section? Where it's
no,
okay.
Right under that database db.collection, huh? That one?
Yeah. So aggregate is not a global method. When we call aggregate, we must call it from a collection. So here I was like generous enough to add the collection name. But inside the slides, you will see mix. You will see a mix. Most of the time, you will see me using aggregate, 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 or just aggregates. But this will be equivalent to this, to this, to this. Sometimes I just mention this, sometimes I just mention this. But every single time you aggregate, you must aggregate over the collection. So this is correct syntax. This one is not correct syntax. It must goes on a collection or model. But just for a shortcut, sometimes I just remove it. But you always need to call aggregate on a collection. Okay? And here in the slides, you're seeing I called aggregates on the zip code collection, which represent this data.
Okay, thank you.
Yeah, sure. Any questions? Sort, skip, and limit. You sort, skip, and limit. I mean, seriously, guys, you just sort and skip and limit. So here, also on the same zip codes collection, I'm going to aggregate. And for the first time, you're seeing a pipeline that has 1, 2, 3, 4, 5, 6 stages. The first one is going to filter the collection and keep the documents with the state of Iowa. Second one is grouping by city to calculate the population, the sum of population. The third one, we beautify the data. And as you can see, I'm just renaming city and keeping population as is. Now I have all the cities. Stage number 4, I sort them in descending order. So when you pass -1, it's descending. And when you pass 1, it's ascending. So you sort these results in stage number 4. In stage number 5, we skip 10. And the last stage, we just pick 5 documents. And we send these 5 documents as a result. Now we call these techniques pagination. So if you didn't hear about pagination, it's about sending the results as pages. So let me elaborate a little bit on that. So let's say you have 1 million results, but you don't send them 1 million results all to the client. So how can I send this as pages? So you have to first pick the page size. And let's say the page size is 10. You want to send them 10 at a time. And then you need a page number. So let's say I wanna pick page number 1. So you wanna send the first 10. You know that all your data are sorted already. And you wanna send the first 10, the second 10, the third 10. How do I send the page, the first 10? So you basically you skip size times number, and you limit always by the size. So if I want a page number 1, then you skip 10. Oh, that doesn't work. Then -1. So in order to get the first set of results for page number 1, you skip 0 and limit 10. So you get the first page. If you want page number 2, then skip 10 and limit by 10. So you get the page number 2. If you want page number 3, 3 minus 1 is 2 times 10 is 20. So you skip 20 and you get back another 10. We call this technique pagination. There is a plugin that you could add to Mongoose to automatically paginate your results, or you can simply implement pagination just by playing, calculating the skip and limit values. So you send the results in pages. After I click the next 10, you show the next 10. Next 10, you show the next 10, and so on. So here is an example of how do we do pagination. Any question?
Yeah, so skipping means it's not completely omitting the data the first time, but it's there, but it just takes turn to show.
Yes. Yeah, the first query, for example, you just pass here, skip 10 and limit 5. So you just take these 5 documents from the database and send it back. Now when the client, hey, I want the page number 20. So you just skip, for example, 19 pages, and then you take another 5 documents and send it to the client. So basically, yeah, sending only the data that's in chunks, in pages. Any questions? All right. And now we want to learn really special and very dear to my heart stage. This stage is very close to my heart. I like it. I'm going to use it a lot this afternoon. It's called unwind. So it's really wonderful. You'll see now why.
Professor,
here-
I
Yes,
have questions on previous part. If you have time.
yes, I have time.
So previously we grouped the dataset based on some key or property. So if there is any way I can group the result of the without any field or property, like I want to count how many record has been stored in my collection, or if I want to say how to calculate the running sum of a collection. So that time I don't have any ID. So is there any way? I mean the group ID.
You can use just group. You can use just count in this case. You don't need to use aggregation pipeline. Just use count and set the query, and that will send you the number of records. Or if you add someone, and basically you have some sort of a key that you group by, then that's something you can use group by. But if you don't have a key to group by, then your operation is not a group by. Your operation is just match or query. And if at the end, you just want to see how many elements you have.
Okay. So is there okay. Thank you, Professor. Yeah, I got it. I forgot
Yeah, so
about the
collection,
count KPI.
yeah, count and pass query. You don't have to aggregate or group by.
Okay.
Let's go back to the stage that is very close to my heart. So here we have also collection. So I have a collection that has this document. And here I have an aggregation on the same collection, assumably, that has two stages. The first one is unwind, and the second one is also unwind. I have a pipeline that's going to read this data, unwind first, and then the results will be input to the next unwind, and then I get other results. Let's see the first unwind. So when you unwind by color, color here is an array. When an unwind by color, you get one red medium large and one blue medium large. So one red ml and one blue ml. So in memory now, I have this shape, which is really what it unwind means. It means spread this array into separate documents. Now, even though these are in memory, they have the same underscore ID, you cannot persist these results back on the disk. In memory, that's fine. You can read it this way. But you cannot persist this in a disk because now you have two documents that have the same underscore ID. Now, this data would be input to the next stage, which is unwind size. So we get one red medium, one red large, one blue medium, one blue large. So basically, this is the second unwind. I kind of spread all my array values. Now you're probably now looking at this and you're thinking, oh, this is 100% opposite to group by push. Yes, this is 100% opposite to group by push. And the next example is showing you that.
Professor, could you
Yes.
repeat again, please? I don't get it. Yes. The unwind part.
Yes. So here I have
in the previous slide, please.
It's the same example. So
okay, good.
If you're still confused, I'm going to come back. So
okay,
I'm going to aggregate over this data. This data have a property called color, which is an array. When I unwind color, I just spread this array. So instead of having one document with value here and ID, and the value is array, you will have two documents now for every single value of the array. So when unwind color, you get one red and one blue. So I spread this data this way. Is this clear?
Yes,
How
I get
unwind
it.
worked? Good. And that was the same what I mentioned in the previous slide. Look at it. When an unwind color, look at color, this is the data. I say one red medium large and one blue medium large. So I unwind the color here. So instead of color being an array of red and blue, now color is the first color is red, and I maintain the other values. And the second document has the second color, and I maintain the other values. And now when this is an input to the next stage, I'm unwinding the size. So basically I have one red medium, one red large, one blue medium, one blue large. Now I have 4 documents in memory to work with. That's the unwind
okay. Thank
action.
you.
Yes, good. So here when I unwind the color, I get one red, one blue. And when I pass this data as input to the group by, I'm grouping by underscore ID. So I'm going to aggregate all the underscore ID, and they have 1, 1. So basically these two will be combined. And what I'm doing is I'm creating a property called color, and I am pushing the color inside of it. So when I push red and push blue, basically we came back to the original data. That's why the unwind is 100% opposite to grouping by and pushing. Any questions?
So I have questions, sir.
Yes.
In this case, ID will same. So the can we use unwind for searching or something, because the ID after unwind ID is
Unwind
totally
doesn't
same.
search. Unwind just spread an array. Unwind spread an array. That's what its job. Doesn't search. It doesn't. If you want to search, then you have to add another stage, which is match. Okay. Every time you want to search, then you have to use match. Every single time you want to spread an array, then you use unwind. And now you should start thinking of how do I get the only brand? So maybe I should spread all the brands and then filter them by the brand that I want to send back. And then I send the brand ID. And that's the technique that we will use this afternoon.
Okay, thank you, sir.
Sure. Any other questions? Take a break for 10 minutes. After the break, we will discuss how MongoDB high availability works, the replica set, and how the scalability works with sharding. Let's take a break for 10 minutes.
Professor,
Yes.
understand that you love to spread your heart to
Yes.
that.
You appreciate this operation, right? This stage?
Yeah, I like it.
The second part of this lecture is focusing on the mechanism that MongoDB follows in order to provide high availability and the approach also MongoDB provides in order to scale up, so for scalability. Let's talk first about high availability. The concept of high availability is that produce more fail tolerance at scenarios for your database. So if you are using a single point of database, one instance is your app, and if for any reason this instance failed, the entire application fails. But if you do have some sort of a backup, kinda, and a mechanism to switch to the backup immediately when your first node fails, now your application can now resume working by connecting to the backup copy. But this backup need to be live backup. So it's not like an old data that's 1 hour old or 1 day old. It needs to have constant updates with the main nodes in order to be really used as the backup copy as a replacement for the first main node when it fails. And MongoDB, especially when you spin an instance on the cloud, and the cloud server is called Atlas, and they can provide you with a free instance with some limitation in the cloud. They provide high availability through a default size of what we call replica set. So what is a replica set? A replica set is a structure that consists of at least 3 nodes. And what I mean by node here is not node server. What I mean by node is server, DB server. So node is a DB server here. And one of these 3 nodes is going to be the primary node, and other nodes can be any other type of nodes. So what are these type of nodes that we can add to a replica set, and why the least size is going to be 3? So here is your application. On your application, you have a driver here, and your driving is talking to a database. So first we have primary nodes. A primary node has full data. All the data is read and written to the primary node, and that's good. Another type of node is secondary nodes. A secondary node maintain live data with the primary node, and for now your driver doesn't read or write from it. So also I have a node called secondary. The secondary node always maintain a live heartbeat with the primary node. So the primary node has some sort of collection. It's called op log. And op log is basically the operations log. Every single time you make changes to the primary, you log these changes in the operation log collection. And the secondary node has a live heartbeat with this op log collection. So it tells the secondary, oh, I updated this document, I inserted this document, I removed this document. And now the secondary in a real time updates all the data in all collections in the secondary to maintain kind of a live backup for what's happening in the primary. Another type of database would be an arbiter database. An arbiter is a node that doesn't have any data at all, no data. So what is the job of an arbiter node? An arbiter node can help in case of failure. So why is that? Because every single time your cluster fails, you must have an election. The node cannot just elect itself. There must be an election between the other nodes in order for a new node to become primary. So when your primary node fails, there should be an election between at least two nodes. And that's why the minimum number of nodes in replica sets is 3. So if one fails, there could be an election between two other nodes. Now, in the case of primary, secondary, and arbiter, if the primary failed, I can have an election between secondary and arbiter, and definitely the secondary is the only candidate to become a new primary. And now your application resume all the operations with the secondary to read and write as the primary is filled. Now the primary or MongoDB doesn't automatically or magically recover the primary. When the server fails, it needs an admin to come and inspect and restart or see what services are failed and then bring it back to life. And when that happens, the failed node rejoins the replica set as a secondary. So as your application is talking to the primary and the primary fails, now your application is going to buffer all the requests from the application until it resumes communication with the database. Now the primary failed, election. Now the result of election between secondary and arbiter, I will have a new primary, and now your application will resume read and write with the new primary, and I have an arbiter. Now, in case of this primary fails, your cluster fails because we cannot have an election, right? Now, after we resume with this new primary, all the buffered operations are resumed to be sent in here, and your application resume its normal life. Now, when an admin recovers this primary, the primary rejoin the replica set as a secondary this time, and it will maintain real live heartbeat with the uplog of this new primary and sync all the updates. Now, in case there were an update that was merged inside this old primary before failure, and the secondary did not have them, now this new secondary node is going to eject all of these updates out and put them in some sort of a file for the admin to review and merge if necessary. So that's basically what happened with when a scenario of failure happens. You must have at least two other nodes in order to have an election. And that's why the minimum replica set size is 3. Now, do we have other type of nodes? Yes, we have also a node called hidden. And hidden node doesn't have data. We also have a node called delayed. I can have here also hidden. I can have here delayed. I can have two secondaries if I want, just in case there will be an election. So this secondary also might become a new primary, just to increase my fail tolerance, right? A delayed node will have some data, but a delayed node cannot become primary. Only secondaries can become primaries. Arbiter cannot become primary. Hidden doesn't have primary. Delayed, although it has some data, cannot become primary. Why? A delayed node does have data on schedule. Let's say every hour it syncs. Every day it syncs. Every week it syncs. So in case a primary node failed, I cannot bring back new data that's 1 hour old, or 1 day old, or 1 week old. That's why a delayed node cannot become a new primary. Note here that all of these nodes contribute in the election. So in case there is an election, always all nodes can contribute in the election, but only secondary nodes become primary. So if I have two secondaries and the primary failed, now the election would be based on the secondary that has the latest updates, the freshest ones, the one that have most updates. That's the one that should be candidate to become the new primary. So that's what happens when we in MongoDB to provide high availability. Now with all these concepts, we have two more scenarios. The first one is read preferences, sorry, and write concerns. Let's discuss these concepts. So they have a primary, you have secondary, and you have, let's say, another secondary. Here is a replica set. And now I can, since I have two secondary nodes and I have one primary, it's not fair that your application read and write to one node. To increase performance, what you can do is to have your application read from a secondary and only write to the primary nodes. So now you have a dedicated server to write into and another dedicated server to read from. Now, any secondary node has a live heartbeat. So if there were any written changes here, they are immediately reflected here. It's a matter of few milliseconds. So probably we could increase performance by changing the read preferences to write to the primary and read from secondary. This way I have dedicated server just for read and dedicated server just for write. So we really get a lot of advantage when we use a replica set. Another implication that we get with the replica set is write concerns. And write concerns are basically knowing whether the data is successfully persisted. So if I have primary again, let's say I have secondary, I have another secondary, and let's say I have also an arbiter. More fail tolerance in this replica set. So if your write concerns is set to 0, if your application send write can only be sent to primary, right? They can never change. You cannot write to any other nodes. So when you try to write to the primary with the write concern of 0, even if the data didn't persist 100%, the driver is going to send you a confirmation of this write immediately. So your callback function will trigger even though the write didn't succeed. That's probably just weird. The default write concerned in the replica set is 1. So after you send a write request, once this write is correctly persisted in one node, which is the primary, now you get a confirmation with the callback function sent to your application. Just to make sure that things are persisted in a safer way, you can set the write concern to 2 in this scenario. And 2 only means that, hey, Mr. Driver, call my confirmation callback function only when the data is persisted in at least 2 nodes. So one primary and one secondary in this case. So the secondary synced the changes. When 2 nodes successfully persist the data, now your application callback function is triggered. And for a replica set of 3 nodes of primary, secondary, and an arbiter, you can set up to 3 here. Write concerns. I'm not sure how important this data is, but if you set it to 3, it only means that only when the data is persisted in 3 nodes, then your callback function is triggered. So it's a way of guaranteeing that the data is persisted 100% in multiple places before you get to confirm to the client that this transaction is done or whatever. So that's the meaning of write concerns. Any questions?
Professor,
Yes.
I still not understand what the purpose of a RKBC not here, because it doesn't have any data and it cannot become the primary in case of the application fail.
So if this one completely fail, if we left with one node cannot elect itself, so this one would be a waste. So this why if we add an arbiter, now we can have an election, and so this one could win. So here having an arbiter really good thing, don't you think?
So it's just stay there for election when the application
Who's
fails.
going to decide? Yeah, who's going to decide this node should be elected? There should be an election, and you can't have election with one person. At least 2 people should contribute in the election. So having an arbiter support node is important in this case. So it could elect any secondary node since it does have data. So that's the job of an arbiter.
Okay.
Professor,
Yes?
is there a limit for a secondary node? Like if we want to have more secondary nodes in our replica set?
Your bank balance, how much money you have, that's the only limit. So if you have money, buy more servers and have more secondaries. Now, if you have less money, then probably you should be on more economic and have less secondaries because they are expensive if they are full servers. Yeah. So that's the limitation. Any other questions? Yeah.
Professor, so
Yes.
when the application connects, they will connect directly to the primary, or they will connect to the load balancer or the cluster.
Currently, we don't have a load balancer. We have only one node that we talk to. So every single time you have a connection string, even though that you have primary, secondary, arbiter, whatever, your application by default read and write from the primary and done. These are kind of hidden to you. Okay, they do their job, but they are just hidden.
So which server will be contained on the metadata for the primary server, secondary server, arbiter server, and hidden server?
So yeah. So when your driver, you send, this is the native way of connecting, by the way. When your driver connect to this primary, immediately the primary responds back with information about this entire structure. So that's why we call this connection seed list, because it automatically reveals all its structure to the driver. So the driver really knows what to do. Now, if you configure as you're connecting to your database that I have, for example, write concern with a number, or I prefer to read from a secondary node, then the driver will have the address of the secondary node and send all the read requests to the secondary and keep the write request goes to the primary. So it depends on how you configure basically your connection string. But the connection string by itself is used as a seed list to reveal this entire structure. So if there was any other options that you pass as the write concerns or read preferences, the driver will completely know how to work with this replica set. And now if it happens that you create an instance on Atlas and you try to copy the URL from there, you would probably note some more servers, or sometimes they just use one server as a seed list, and then all the extra options that are passed. So now you will understand it better. Okay.
So when we want to add one more second node, do we need to restart the primary?
No, that's not necessary. You just issue a new command on the database level and have a new node joins the replica set. Creating a replica set is just a matter of having some command, having all the IPs and ports of all the servers, and create them as one unit.
That's okay, thank you, Professor.
Yeah, you're welcome.
Professor, I have questions here.
Yes.
Since all the read requests come from the secondary node, so
if you did configure this, then yes, all the read will be from the secondary. By default, you don't read from the secondary. By default, you read from the primary and write to the primary.
If I set a read preference from secondary, it will give my strong consistency.
Say it again.
If I set a read preference secondary,
yes.
Yeah, that time will it give me the strong consistency?
I don't know what you mean by strong consistency.
Okay. This term refer to that all the most recent write data will be replicated among the secondary node. Like
yes,
previously. Okay.
Still the same. Yeah. Again, the secondary node in real life time replicate all the changes. So whatever changes happen there, and remember MongoDB provide atomicity on the document level. So yes, you get immediately.
But you mentioned that
yes,
when electing the secondary node, it will be based on the most recent data which database has. That database will be the primary. So how it will be the criteria if both database has the most recent data?
I'm sure there is some sort of an algorithm or mechanism to detect that. But I didn't get that deep in how this algorithm works.
Okay. And all right. Yeah.
Yeah, but it has to be with in regard of how many updates it's synced. If we have two secondaries, if you have one secondary, you don't need to decide a lot. But if you have two, then you have to check what is the latest update that this secondary did, and probably based on the number of updates, you could elect which one has the higher updates.
Okay. All right. Maybe it is the eventual consistency here. So therefore, they might get elected based on the most recent data.
Yeah. Possible?
Yeah, thank you, Professor.
Professor,
Other
I have a
question?
question. Yeah.
Yes.
If we have multiple secondary node, will the request be distributed to multiple node, or how the request distributed?
I'm not sure if when you said read preferences, you would read from multiple secondaries or not. And if we're gonna read from multiple secondaries, we would need a router, and I don't think router is involved in here. So I would think that most probably one secondary would be involved, but I am not sure about that.
Thank you, Professor.
Any other questions? Let's finally talk about scalability.
Sorry, Professor, I have one more question.
Yes.
So you mentioned that if the primary node gets failed, so that time the secondary node take over.
Correct.
So whenever, I mean, if there is any uncommitted request, like uncommitted write or read or update request, I mean the upsert request.
Yeah, they are ejected.
So, yeah.
When the
primary
failed node
rejoin,
joined as a yes, all these changes will be ejected, so they will not be merged.
So who will take care of that for a rollbacking the?
You.
Okay. Okay, I got it.
Yeah. So when you
So
because
who
you
will
are the
inform me
one.
that?
Yeah, because you are the one that's going to fix the failed node. So you are the one that you will see that, oh, we have these changes that were ejected. So you are the one to decide what to do with them, either to merge them or just ignore them.
So who will inform me that there is some uncommitted data?
The recovery process, as you're trying to recover the failed node, and the failed node rejoins the replica set, you will immediately get a report of all the ejected fields and the log files and all.
Okay. Okay. Whenever I'll try to recover my failed node to my cluster. So that time my recovery process will inform me that there is some uncommitted data, and that should be rolled back, and that should be done by the admin.
Correct. Because you will see all the ejected data and you will decide what to do with it.
Yeah, I got it. Thank you.
You're welcome. So we are going to discuss now how we provide scalability. And with scalability, we need to scale every single time when our data is going to be full inside this single node. So let's say this is a node that's saving data and data and data. And now, just for the example purposes, let's assume that 1 million records or documents inside this collection is just capping the hard drive and memory of this server. Not to mention that, let's say you have on this collection maybe 5 indexes, and these 5 indexes are filling up your 32 gigabyte of memory. And this 1 million records, let's just assume that they are filling your 1 terabyte of hard drive. So your hard drive is almost full and your memory is also almost full. So the way we deal with this is by sharding this database. And shard basically simply is cutting the database in half. And notice here when I say in half. So when you shard a database, you completely split it up 50%, 50%. So when now this is sharded, now I have 50% of the collection here, and another 50% of the collection in here. Now I have still 5 indexes here to index this 50%, and another 5 indexes here to index this 50%. And now these are taking 16 gigabytes in memory each. And now I filled the hard drive of each of these two machines up to 512 or 500 gigabytes. So I still have half the server empty. Now performing any query in each of these servers will be probably 50% faster, because I don't need, for example, to scan an entire collection or process something for the entire. Now everything will speed up. But now the problem that you have is when your data is split into two places is, let's say you have a read or write query to these two machines. You need to know, is your data here or your data here or in both? If you have to write, should you write it here? Should you write it here? Because you need to maintain balance 50%, 50%. Now, for that reason, when you shard your database, you need a router. And a router server basically is going to decide whether any query should be sent to one or more instances of the shard to fulfill your query. So any request for aggregation or query or insert need to pass first through the router, which will going to decide which server is going to handle the request. And we have two kind of algorithms that I know about that the router could use. It's either by range basis or by hash function. So range could be like, for example, if two, let's say even odd logic, it's certainly not, but assumably even odd. And if it's a hash, then you will pass the query through a hash function, and the result, math result of the hash function will tell you whether the query should go to one or both servers or more servers. In order for the router to decide that, it needs something called shard key. And what is the shard key? It's something that you have to decide when you create a shard. Shard key is simply an indexed field that exists in all collections. So an example is underscore ID. We can use the underscore ID to determine the logic of where we go in between all the shards. Now at any point you need to shard further. So you split, you create a third machine. And now 33% each would consist of the collection. So the collection would be 33% of it here, 33% of it here, 33% of it here, and your router will route based on the shard key where your request should go. Now note here that what if this 50% of node failed? Now you lost 50% of your collection data. Every single shard should be a replica set in order to provide availability for the amount of data it has. That's for sure. So that's how MongoDB scales up using sharding techniques. When we shard, we split the data completely in equal amount between all the shards. And when we do create a shard, we need to create also a router and set the shard key. And the shard key is used in order to decide how are we going to route the queries based on either a range or hash-based functions. And every single time you need to remove one of your shards. Now, when you remove this shard, for example, before this shard is removed, all the data is migrated back to consist 50-50, and then this shard will be removed completely. And that's how you scale down in case you don't need or you deleted some data. Any questions?
Yeah, Professor, yeah, I have the question.
Yes.
So every time when you add new node or just remove any node from the cluster, so that time, as per the knowledge that you have to change your shard key. You have to update your shard key.
I don't think you update your shard key. Shard key is selected from the beginning.
So how
you
your
don't
hash
update
function
it.
will
If
work
you want to
when
update it, the entire shard will be recreated.
so
So you don't
how
want to
your hash function will decide which database will take care of the request?
Before you create the shard, you pick the shard key. You don't change that. If you
No,
want to
I'm
change the
asking
shard,
the hash function, Professor.
yes.
No, my question is that hash function will decide which database will take care of the request, right?
Correct.
So hash function, how the hash function will decide the request will handle by which database or not?
Math and algorithms. It's math
Yeah, I know
and
that.
algorithms.
I know that, but
read the source code. The source code exists for free.
I know the mechanism from the consistent hashing. So that thing, that technique, I know that, but actually I am confused here. What? Okay, I got it, Professor. Okay,
I don't have information about that. It's outside the scope of this course.
Okay. Yeah.
Yeah. Any other questions? Good. That's it for today. Yes.
Professor.
And yes.
I have a question, but it's not related to this particular topic.
Okay.
For example, in using SQL, I usually like use a trigger to operate like some operation. For example, if I want like to track all the some actions like that, like some actions like doing like back the user, for example, logging, and then I want to log those kind of information in a table. I can like implement a trigger like every update or every insert in like that's happened in my database, like it will operate in action. But what about like MongoDB? How can I handle or like how can I like, implement this kind of operation to keep track of?
I lost you.
Sorry.
Yeah,
My
give me more
English is not that
precise.
good, but I will. Okay.
No, give me more precise. Rephrase your question.
Okay. Yes. For example, in MySQL, you can like use triggers. And with PLSQL, we can use also like triggers also. But I wanted to know if there is like some kind of operation with Mongo.
Yeah, but I'm not sure about Mongo native API, but I know such things that exist on Mongoose. So I'm not sure if Mongoose does provide that as like a third-party plugin, or it uses, or it acts as just a wrapper to a native API in MongoDB to trigger all these changes. No, you know what? I changed my answer. So yes, I remember there is something called that triggers something in MongoDB, and especially for transient values that needs to trigger something at certain time and trigger something. There's something that exists in Mongo API for that.
Okay.
Yeah.
Thank you.
Sure.
Professor.
Yes, one second. I want to add one more thing. I think I used that when I needed to close auctions. So I set this time as transient time, and that when it due, I triggered something to close auctions in an application. Just an example. Yes, Abdullah.
Okay.
Yeah.
Okay, thank you.
Sure. Yes,
Professor,
Abdullah.
and the architecture and the architecture we have discussed earlier about the sharding. There is another drawback what I have noticed. I have the questions actually. I'm not commenting that it has the drawback. Since we are sharding the data into multiple node, so that time if any node get failed, so their replica data who will take care of it? Will another node, right?
You're trying to shard, and at the same time you are failing.
Suppose I sharded my data into the 3 database, and
Okay.
suppose I sharded the data based on my region, like regional data. One region has some data.
Good.
So all of a sudden, one of my regional node has been down. So other
Do you have
regional
high availability for that region? Because every single node should have high availability. So every single section of the shard should be a replica set by itself. If not, then you are not providing high availability. You're just scaling up without taking care of any failure. So every single node in any region should be a replica set to provide high availability.
No, okay, Professor. Yeah, I actually, since it is the solution what we are discussing now, it will be taken care of by the third party who will maintain this. That things actually I learned here, the sharding technique. That means I will take care of that. I thought that.
Sharding is just a technique for scalability, not for a very high availability. So it doesn't take care of failure. Sharding is just like, I have too much data here, let's split it. Let's scale horizontally. That's it. Now, if you're worried about failure, then you should always think of replica sets and divide your replica sets in multiple regions. So in case of one region get fire or power outage or something, whenever you have backup in some different regional place, then you could recover your data fast.
Yeah, yeah, I got it. That means my cost will be high. Yeah, okay, yeah. Okay.
Any other questions? Yes.
So, like, all these concepts are the underhood of the database. What's going on? So, what exactly? It's really a lot of things I can't comprehend at all. So, I just understand that what we are doing routing is like separating out the data, the whole chunk of the database we have, and then it's separating out, but we don't see it while we are programming. That's the concepts I can take.
Correct. As a developer, if you're using a database as a service, for example, a cloud database instance, and for MongoDB, all you're probably going to see is the connection string that has these options for the replica set. So as a developer, probably you're not concerned how these are changing and stuff, but if you copy this string, you will understand that, oh, this is something good, and I know that my database now provides some fail tolerance. Now for sharding, I don't think developers care that much about sharding other than the DBA. An administrator should be concerned always monitoring the performance of the queries, informing the developers if there are any slow queries, should be monitoring all the indexes and see their performance and whether they fit in memory or not, and split basically the database or shard when they see any kind of that this is the solution that's going to solve the problem. Yeah, I agree with you that this is probably not a developer perspective of but knowing these things, I believe it will make you one step to become a little bit more better developer than other developers that they don't know how these details.
Okay. Thank you.
You're welcome. Any other questions? Right. Let's meditate and go to lunch. Remember, after lunch, we will connect back and solve some aggregation queries that we missed yesterday, do a quick review, give you some guidelines to how to prepare for the midterm exam on Friday. So let's meditate now and go to lunch. Let's sit comfortably, close our eyes, and start the meditation. close for you.